right, problem set 22, question number 6. This reaction asks, says provide an electron pushing mechanism for the aldol reaction of 2 molecules of propionaldehyde. So let's go ahead and do this. This pen is too thick. Let's see here. There we go. It says it's in hydroxide, so we know that we are under basic conditions. It's also at 10 degrees. This is reaction conditions that you don't have to have memorized. In this case, the key here is that we do have hydroxide, and we know that this is in equilibrium with the enolate. So what I'm going to do is draw our hydroxide, and then I'm going to come in, and we know that we're going to form our enolate, just as shown. Now, one of the things you have to keep in mind is that this enolate here is in fact planar because of the resonance that is drawn between the oxygen and this double bond. So when you have another equivalent of your aldehyde present, we know that an enolate will react at the carbon, that is alpha to this carbonyl, will attack the aldehyde and push the electrons up. Again, this is still reversible. Now, at this point in time, I think it would be important to go ahead and show you the counting of the carbons. I think this is really important as you're doing this type of chemistry. So what we're going to do is we're going to count our carbons, 1, 2, 3. I like to count then starting at 4 on the next compound I'm reacting with. 4, 5, 6. This will help me decide how to connect everything. We're not going to flip anything over and make it look pretty. I'm just kind of showing you how you can make sure you don't miss carbons. It's so easy to. I've just drawn 3 carbons, 1, 2, 3. I know that on carbon 2, that is where carbon 4 is bound. So I'm going to draw a line up. That's my carbon 4, and then 5, and then 6. On carbon 4, I know I have an oxygen, and I attacked it there. So that'll be an O minus. On carbon 3, I have this hydrogen that used to be from the initial aldehyde. Okay, I pushed those electrons down to make that double bond. So here we now have our intermediate. Notice here though that this O minus can be either forward or backwards. It could either be wedged or dashed. I'll just draw it this way at first. And then another thing you should note is that this methyl here could also be wedged or dashed. The starting enolate we know is planar, and as it attacks, you could end up having both configurations here. So what's going to happen is you will have all these 2 stereocenters can be either R or S. That means you're going to end up having 4 different products, okay? Now this doesn't say that you do have a workup step, but we are just going to, whoops, go back. We're just going to assume that we do have a workup step. So typically you have water and then maybe just a small amount of acid that you would add at the end of your reaction. I'm going to draw this a little pretty. I know that I have 1, 2, 3, 4, 5 carbons in my structure here. So why don't we do this? 1, 2, 3, 4, 5. And then what I'm going to do is draw in what we have. So I've got my aldehyde here at the end. And then this is my alcohol. And then we can pick either. This is one of them. The other stereo center could be switched. And then it could be switched the other way. And we still have one more. And you can go through and determine your R and S if you'd like. On an exam, you would need to, I prefer you draw all 4, unless I specify otherwise. So here, this is our product. I didn't show the workup step here. Let me show that real quick. typically you would have another step with water and a small amount of acid. In this case, it just says hydroxide, but you typically don't isolate these just from hydroxide. So on an exam, I would have another workup step. And there you go. There you have it. That's the aldol reaction of 2 molecules of propionaldehyde.